So my presentation is entitled Back to the Land Theory and Assessment of Land Degradation in Southern Europe. So what I want to show here is not a definition, because I don't want to use this definition. I don't want to use time, according to my friend Pandi Isdruli. I don't want to spend time about definitions, but just to tell you that I will not use this very well-known definition for desertification, because it's really very general, and of course I like it, but I prefer to change a bit. So I prefer to show you a photo gallery. A photo gallery, I put just one title in each of these photos, just to stimulate you to make a comment in your hand, just to understand what is the gradient, what is the typical geographical gradient I want to show in this photo gallery. This is a desert, and I put here a title, Desert Simplicity. Of course, this environment, this ecosystem is not simple. It's totally complex, but it's just to stimulate you to make some comments. And then we are moving to the Mediterranean Europe by looking to another picture, which is a picture taken here in Greece, very close to here. And I put another title here, just to make some comments about it. The third slide, we are approaching what I want to show you in a few slides. This is arid land, poor vegetation cover, but it's a typical environment which is functioning. And again, another picture, badlands. This is a typically naturally degraded landscape, but with some ecosystem functionalities, plenty of biodiversity. You can see over there some woodlands. We are in southern Italy. And a very typical landscape in southern Italy, southern Spain, and in Greece too. We are in a forest, in an agroforest system, and with the main factor of land degradation is forest fire. Now I'm introducing you another factor of land degradation, anthropogenic activity, human activity. Here we are in a degraded landscape, again, due to mining and anthropogenic activities as well, in central Italy. And the last slide, the last picture, is this. I like so much this slide because, for me, it's the final synthesis of my background, because my background is very mixed. It's in between biophysical science and human science and social science. So this is a typical interplay in between biophysical factors, the soil, the arid soil, you can see soil crusts, and an environment which is a city, a very compact city. Probably some of you will recognize Barcelona here. Here is a photo taken from the Agency for Water Management in Barcelona, in Spain. But it's very, very nice for me, just to help me to introduce you the feeling, the meaning of my presentation. So what I think is that narratives about land degradation, instead of definition, are better to tell you, to communicate you about my ideas after 10 years of studying desertification and land degradation in the Mediterranean basin, about the complex interplay in between several biophysical factors and socioeconomic factors. I put here two photos. Both of them are taken in Greece here, and at the end of the presentation we will discover what I have in my mind for these slides. But first of all, I want to introduce you some complexities in the narrative about land degradation and desertification in the Mediterranean basin. As you can see here a storyline with some very important facts. I select some facts very random. There are a lot of additional factors here to move about the narrative in the history of the desertification concept around the world, and especially in the Mediterranean basin. But I think here there are some milestones that we have to think about before giving some definitions and giving some framework to study land degradation in southern Europe. So just one slide to come back to the definition. I want to provide you another definition, not for land degradation, not for desertification, but just for land vulnerability of desertification, which is the state of a local system which is depending on the quality of vegetation, soil, climate, and land management based on socioeconomic issues evolving over time. So in this definition, you can find two important concepts. The first one is space and space variations, and the second one is time and temporal patterns, of course. The next slide is very traditional because it makes a summary of land degradation drivers in the Mediterranean basin, dividing it in biophysical drivers and socioeconomic drivers. But I don't want to catch your attention on that, but just to introduce you additional keywords about land degradation drivers. I like so much to put the attention to these different keywords and concepts. So complex systems, fractal system, entropy, diversity, fragmentation, and of course, when you refer to the Mediterranean basin, especially to the socioeconomic issues in the Mediterranean basin, you have also to address issues such as informality and deregulation. Let me give you just one example: deregulation in planning. How to build up a residential settlement around a big city in the Mediterranean basin. Probably you have to address a problem of deregulation in planning, just to give you an example. So for me, the research priorities in this presentation and for the future in my activity will be just a bit more attention to logical frameworks instead of definitions. Of course, second point will be permanent monitoring, especially about biophysical drivers. The third point will be integrated assessment, how to integrate socioeconomic issues and biophysical issues. And the fourth point in this presentation will be complex system, how to approach and how to evaluate complex systems and how to translate this information into policies. So one example for complex systems is this. It's a typical framework for Mediterranean basin complexity. It's not a typical deep sea IR framework from the European community. It's not exactly the same because we have only drivers, we have pressures, and we have syndromes. But I show you this just to highlight the complexity of the system according to the arrows, which are moving very, very crowded in this part to this part and so on. So you can see many issues which are interlinked in between, and the difficult thing is to assess and to have information about these different issues. I want to introduce another complex framework just to finalize what I want to communicate is this. Usually I prefer to use three different issues just to have a summary of the different processes of land degradation in the Mediterranean. So on the left you can find processes, soil erosion, for example, forest fires, soil salinization, land abandonment, and so on. Issues, research issues such as indicators and techniques and so on. And of course the third pillars will be the affected landscape, so natural landscape, traditional rural landscape, but also intensive crops, dry agriculture, pastoral landscape, and I want to add now a last line, which is peri-urban landscape, so land around big cities which are expanding very fast, and we will see later on. So, just to conclude the first part, which is about logical framework, what I want to introduce here is a very, very simplified framework according to three dimensions for the anthropogenic factors affecting land degradation in Southern Europe. It was published on a journal, on the International Journal Science of the Total Environment, but especially I like the different time pattern of the framework. The first dimension is time, and what is interesting for me is to try to divide two different variables. The first one is the fast variable. What means fast variable for me and for complex adaptive system theory? Fast variables is a variable which is changing very rapidly. Of course, a slow variable is exactly the opposite. It's a variable which is very, very stable over time. The second axis is the space gradient. So if you want to classify factors of land degradation into different different factors, you can see here broad range, I mean broad scale, broad spatial scale factor, and narrow scale factors as well. So another possible classification for space factor. And of course, I think it's important to add a third axis, which is the sectoral axis, which is formed by different fields, different issues. I found this very interesting in my case, but probably there are some more. The institutional factors, cultural factors, social factor, economic factors, and financial factor, as well political factors. The second point is giving you some information about my activity in permanent monitoring. I don't want to stay on these issues. We are plenty of indicators, of composite indicators about land vulnerability to degradation and desertification, so I don't want to add an additional indicator. I just want to show you how to change from a linear thinking approach using, for example, one very well-known indicator of land vulnerability to degradation and moving to a complex thinking. In this case, I will use a very simple indicator. Probably some of you knows this indicator well. It is the environmental sensitive area index proposed in the framework of the Medalus 2, if I don't remember bad, a European project from Kostas Kosmas, University of Athens, and Geoffrey Wilson, University of Plymouth. And well, some details are reported in this slide, but I don't want to introduce details. Just to inform you that this index is a score index ranging from 1, which means no vulnerability, and 2, which means very high level of land vulnerability to degradation, using some indicators. You can see here soil indicators, climate indicators, vegetation cover indicators, and land use pressure indicators. This is a very typical example of a linear thinking. And the next slide will confirm this, because you have maps, you have some different maps: soil quality, climate quality, vegetation quality, and land use pressure quality. You make an overlay in a GIS environment, and at the end you have a map. This is a typical map of vulnerability, and the colors are telling us the difference in the level of land vulnerability in this region, which is in Italy, but it's just to give you an example. At the end, you have a map. This is a typical example of a linear thinking. Another typical example is this. You have two maps, a diachronic mapping of the land vulnerability in Italy from 1960, according to the data availability to us, to 2010, so 50 years of evolution. So you can see here a change in the spatial pattern of land vulnerability to degradation in Italy. But again, this is another example of a linear thinking, so I don't want to concentrate on it. Another typical example of a linear thinking is to calculate an average of this score, the composite index of land vulnerability to degradation. Again, we are in Italy, and to put it in a scatter plot according to time and to see trends. Trends over time, they are increasing, they are not increasing. Okay, we can construct statistical approaches to check if the trend is increasing or not increasing, but this is not the point. The last example here, just to find again an example of linear thinking, is to calculate the average value of the index according to different geographical area. Again, we are in Italy, but this is just an example. And you can see here again some trends. Some are increasing, some other are decreasing. It depends on the specific context, so I don't want to comment on this. What we are moving now is on another typical concept. You remember I was referring to space and time processes. Here we are evaluating a very simplified measure of spatial complexity, the coefficient of variation over space in the indicator, in the composite indicator, which is environmental sensitive area index, by region. Again, we have 5 regions in Italy, and what you can find is another linear trend. We can say here increase for all of the regions you can find there in the graph. But, again, is another example of linear thinking. If you go there, if you simply put the average index with the coefficient of variation, so time against space, you can see a very different path. This is a typical example how to use in a different way and probably more interesting way this data. You can see some patterns which are not very linear, which are more complex, and this is reflecting what we are searching for. We are searching for increasing or decreasing complexity in our system. So we are looking at 3 different systems in Italy, again a case for Italy. The northern part of Italy is moving in this trajectory, the central part of Italy is moving in that trajectory, and so on for the south. Of course, southern Italy is more vulnerable than northern and central part of Italy. But what is the explanation for this trend? The explanation is reported in this slide. We have to spend some time to try to understand this slide. We are studying here the role of selected spatial gradients which are shaping in the recent times the territorial disparities in land degradation in Italy, using very simple analysis, very simple statistical analysis, and very simple index. Again, the environmental sensitive area index. So we divided the period into sub-periods, 1960, 1919, and the most recent period, and we try to understand the importance of different geographical gradients in the increase or decrease of the level of land vulnerability to degradation in Italy. And what we can find, we found a very complex situation according to both biophysical factors and socioeconomic factors. Just to give you an example, here we have a percent change in the index, so vulnerability is increasing, where in the first period, 1960-1990, is increasing only or mainly in southern Italy, and in the next period, 1990-2010, is increasing in another area of the country, and so on for this gradients. You can see many different gradients evaluated in this slide. The urban-rural gradient, for example, elevation, coastal inland gradient, and land capability and population density gradient, and so on. And you can see here very complex situation and very rapidly changing situation in the first period and in the second period. So you can understand why we have this so complex graph, so complex scatter plot here. Another example I want to give you about the possible use of a very simple indicator of land vulnerability to desertification is a very simple method for economic evaluation of land degradation vulnerability. I use this according to a method which is called user cost assessment. It's an economic method. I don't want to suggest this to the economic panel of UNCCD just because it's too simple, but it's just to you to introduce a very simplified example how to use a simple index of land vulnerability to desertification into a more complex framework for economic evaluation. Here is the formula. It's not so difficult how the equation reveals, because here we have the agricultural income by year and district, and here we have the value of the environmental sensitive area index. According to this formula, it's possible to have an estimated income depletion by square kilometer according to a time base and according to the value of the money. In this case, we have euros and we have Italy, but it's just to give you an example. So another alternative use for composite indicator is this, just to enter a composite indicator into an economic evaluation for land vulnerability to desertification. Just to make some more additional comments on this is to introduce some theory about the complex system theory and complex system analysis. I want to use some slides taken from a very recent project, a 7th framework project, which was completed a few months ago and coordinated by the University of the Aegean in Greece. Eleni Briassoulis was the coordinator. I was inside the project, participating as an associate researcher in the project. The name of the project is LEDRA, Land and Ecosystem Degradation and Desertification Response Assessment. So what we try to do is to introduce the complex adaptive system theory to a complex issue such as land vulnerability to degradation in Southern Europe, especially by focusing on definitions and especially focusing on the complex adaptive system paradigm. Let me introduce you just one example for this. We have to refer to this paradigm for a long, but at the end, the example I want to show you is just this, just to identify fast and slow drivers of change according to what? According to simple statistics, according to simple analysis. What are we doing? We are collecting a lot of candidate drivers of land degradation in a place in southern Italy, which is a very small place located in the prefecture of Matera, which is in the Basilicata region, southern Italy. And here we have the same periods. Probably you remember the periods of the map I showed you before. And here we have economic, social and environmental candidate drivers for land degradation. Candidate drivers, they are only candidate drivers, of course, and here you can see a measure of rapidity of change. How they are changing fast, how they are changing slow. The next analysis is more tricky and probably more complex. We are using an analysis which is named multi-way factor analysis. I don't want to enter in the statistics because this is not right in this conference, but of course, if you like, we can provide some details in another occasion. So what happens in this way? We are trying to study the evolution of the complex system according to environmental, social and economic drivers, candidate drivers of land degradation in 1960, 1990 and 2010. So 3 different periods and the evolution of the different drivers trying to modeling the complex system of land vulnerability to degradation in the area. Here is a typical output of the software, which is telling us the rapidity of change of each variable, of each input variable in the system. So you can see here the first year of observation, the second year and the third year, 50 years of observation, and you can see here the length of the arrow as a measure of rapidity of change in the field of all the variables considered. So you can have here the idea of what the complex system according to land vulnerability to degradation is changing in the last periods and what are the main change, the variables that are contributing the most to the change or not. And at the end, you can have a map like this just to classify the area into rapidly changing places, places with small changes in the candidate drivers of land degradation and so on. So at the end you have another map, but which is not simple like the first map I showed you, which is more complex, and at the end you can find gradients. The most important thing, in my opinion, is to understand gradients of land degradation, not only factors and causes. Just to close the presentation, I want to close with 2 slides. The first slide is this. You remember the movie, of course, and this is a perfect storm of global events. But what is the difference in between this picture and this one? What is this one? This one is a picture taken in Greece. We are in Greece, so let me acknowledge my friendship with Greece and Greek people. This was taken 5 years ago after the big fire in Athens. The big fire close to Athens. It was a very big fire, more than 100 square kilometers involving land around the city. Here you have all these factors You can see here economic crisis, you know. Climate change, the place is very arid, as you can see. Water scarcity, because one problem in Athens is water scarcity, as you know as well. Probably energy scarcity, I don't know, but probably you have to assess this. And of course, land scarcity due to urban expansion, as you can see here. And my question, just to leave you with some question, is the perfect storm with us, and how to assess it and how to manage it. How to manage it, it means how to assess this kind of problems, which is typical problem in Mediterranean Europe. It's a problem of peri-urban areas, urban sprawl, and other similar things. So eating soil, the most important things is how to contrast urban expansion and how to contrast soil degradation and land degradation around urban areas. So thank you very much for your attention. Thank you.